My name is Dr. Marissa May, and we'll be looking at prime and composite numbers in this lesson. I think it's important to start out with some terminology that will help us as we move forward in these concepts. And the first one is a factor. Now, before I jump too far into our lesson for today, I have put this note sheet in the description so that you can download a copy of it and take notes right alongside me, mark it up with reminders for yourself, any of those things that help you. I think that as we look at the vocabulary, let's start with a factor. So a factor can divide evenly into a number without leaving a remainder. So for example, 2 and 4 are factors of 8. 1 and 8 would also be factors of 8 here. Now, a prime number means that it's a number that is greater than 1 that has only factors of its 1 and itself. So numbers like 11. 11 is a prime number because the only way you get 11 is to do 1 times 11. 13 is another prime number because you only get 13. 13 only has factors of 1 and 13. Now, a composite number is a number that has at least 3 factors. So for instance, 10 has factors of 1 and 10 and 2 and 5. So those factors become important when we're trying to identify prime numbers and composite numbers. So we'll keep these vocabulary terms working throughout our lesson today, but I want to focus on using a factor tree. So we're going to create a factor tree to identify the factors of 45. Now, you may have seen a factor tree. It's one of my favorite things to do. It just feels like I'm doing art here. But we're going to build a factor tree for 45. And so we start with 2 branches. We ask ourselves, okay, what 2 numbers would multiply to give us 45? And you could choose any 2 numbers you want that multiply to give you 45, but I will caution you not to use 1 and 45. That doesn't really help the factor tree. And so I would encourage you to use other numbers besides 1 and 45. So maybe you picked out 9 and 5. That's the one that came to me. Okay. So now you have 2 branches of your factor tree. We'll work with one of them. Okay. Now we ask ourselves, okay, what 2 numbers multiply to give us 9? That would be 3 and 3. So you see how I built a branch off the 9. Then we ask ourselves, okay, what 2 numbers multiply to give us 5? Well, the only ones that multiply to give us 5 are 5 and 1. When that happens, you have a prime factor and you circle it in the factor tree because that means that side of the branch is stopped. It's finished. Okay, so now we look at this one here. We say, okay, what 2 numbers would give us 3? Well, that could only be 1 and 3. 3 is a prime number, so this branch ends and we'll circle it. This branch ends also, and we'll circle it. Okay, now here's the interesting part of when we create a factor tree. We have to look at all the combinations. So I'm going to list over here. 45 is 1 times 45. That one was pretty given. Okay. The next one we'll do is 3 times, and then you multiply the other 2 branches. So 3 times 5 would be 15. Okay. Another one you get from taking this one, 5, and you multiply these 2 branches. 3 times 3 would give me 9. So those are all my factors of 45, and I got those by using the branches on my factor tree. Now, so how many factors does it have? 1, 2, 3, 4, 5, 6. Okay. Now, we can also use a factor tree to find common factors. So let's do a factor tree for 18 and 24. So I'll do one for 18 over here. I love to do them with even numbers because I get the first branch is always going to be a 2 times something. So 18, I always do it as 2 times 9. And the reason I do that is because 2 is prime. The only way you get 2 is to multiply 2 times 1. So I know that part of the branch ends. And so this one would be 9 would be 3 times 3. And again, those end. So let's write out all the ways you get 18. 1 times 18, 2 times 9, and then do 3 times 6, right? So you've got 6 factors of 18. Now, let's do 24. Again, it's an even number, so I'm going to start with that 2 times 12. Okay, and then 12, again, even, so I'm going to do the 2 times 6. You can see my method is I always take the even numbers and do 2 times whatever. Makes it super simple because then I only have to work with one branch of the factor tree. 2 times 3. Okay, so this one gets tricky when we do the factors. So we know the easy one, 1 times 24. Okay, then we'll do 2 times 2 times 2, or 2 times 2 is 4, times 3 is 12. Okay, and then do 3 times 2 times 2 times 2 is 8. Now you have more, so you have to do 4 times 6. And so those are my factors for 24. Now the question was, remember, to identify the common factors. So what do they have in common? Well, it looks like common factors. By the way, I love to do math in color. So let's see, I got 1. 18's not. 2, yes. 9's not. 3, yes. And 6. So there you go. Those are my common factors for these two, and I can identify those using the factor tree. So I hope that helps. Let's do one more. Well, here's another example. Let's use the factor tree to identify the least common multiples. Oh, this is fun. Now the multiples, I'm going to actually, I'm not going to use a factor tree for this one. I'm going to list out some multiples. Okay. So what I want to do is to take the 12 and the 18, and I'm just going to, a multiple is simply 12 times 1, which would be 12. 12 times 2, 24. 12 times 3, 36. Or you could just add 12 each time, if that makes sense. Add 12 each time. I can keep going, but that's enough to list out there. Okay. And then let's do the same thing with 18. We're just going to add 18 each time. And I'm going to keep adding till I find one. Okay. So 18 plus 18 is 36. Well, there you go. There's the least common multiple. That's the first one I come to. So the least common multiple, we generally call that the LCM, is 36. I can do it with the factor trees, but I just find listing them to be a little bit easier because I just add 12 every time. I just add 18 every time till I find the smallest one they have in common. Now, let me say this. They actually have another one in common in 72, but that wouldn't be the least common multiple. So I hope this helps. Again, the note sheet is listed in the description. If you want to download a copy and have that for your notes, I definitely would encourage you to do that. Let me know if you have questions or if you like the factor tree, if you've seen the factor trees before. Like I said, one of my favorite things to work with. So, all right, friends, have a great day. Bye-bye.